Okay, good morning. Welcome to
FamilyMath number 606.
FamilyMath number 606. So today, following our little exercise with Kelsey Houston Edwards' complex numbers video, we're going to try to look at what the map, when I take a complex number, z, in the complex plane.
Just use this direction.
No, actually it's a good question. Z just represents just some number, a plus bi. For reasons I don't actually really know, mathematicians tend to use z for complex numbers.
Okay.
And they use, what do they use usually for real numbers?
X or Y.
X or Y.
Yeah. So z is just some number in the complex plane. But different than the normal, when we think of numbers like, real numbers. This is almost, you can think of it as being like two-dimensional. It's a two-dimensional number, a plus bi.
Yeah.
And we're going to make a map, and we're going to send that point to z squared. And we're going to try to see what this does to the plane. So we start out with a plane, like a piece of paper. And then we make this mapping, we take every point and send that point to z squared. So what would this look like, or before we even start, what do you think it's going to look like? It's very hard to envision because it's a two-dimensional thing turning into something else two-dimensional.
I think it's gonna have something to do with like a parabola somehow.
Okay. How come?
Because, well, that's what I normally think about when I see squares.
Okay.
And we're squaring something. And normally, like, if you did, like, if you replaced I with X here, like, if you said just, like, bx plus a squared,
Uh-huh.
that would be, like, an equation for a parabola.
Okay.
So, maybe we're gonna get some kind of something relating to a parabola here.
All right, what do you think?
Well, it might look like maybe just it depends like how big the points are. I mean, it might look like a parabola because again you're squaring it, so it might sort of make a curved line.
Okay.
Because when you get bigger points, it'll get bigger.
Yeah, it's actually kind of a little bit tricky, and we're gonna approach it one way, and then we're gonna look a little bit on the computer to help us. But just to get started, what do you think is a good thing we could do to get started?
Well, we can look at like what happens just with numbers just on the axis.
Oh, great idea. All right. Which one do you want to start with?
Like, well, the real axis is pretty easy.
Okay, so we'll look at numbers first on the real axis. So these are numbers of the form a plus what?
Well, just a plus 0i.
0i.
Yeah, no imaginary parts. So numbers like minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, or things like that. All right, where do they go?
Well, they would go.
They just spread out.
Well, except for the positive numbers are going to spread out.
They will if it's 1, it'll say 1, 2 will go to 4, 3 will go to 9.
Okay.
And if it's less than 1, though, it's going to shrink. Like the numbers, like 1/2 is going to shrink to 1/4.
Okay.
And the negative numbers, if it's negative, it just goes to the positive equivalent of it squared.
Okay. All right, so interestingly, well, 0 goes to 0, right?
Yeah.
Yes.
And then these numbers, the positive numbers, go to the positive numbers. As you were sort of pointing out, they don't necessarily go to themselves, but the positive numbers fill up the positive numbers. Right? Every positive number goes to a positive number, and every positive number is hit by some positive number.
Yeah.
Yeah.
Right? But there's only one number that stays, actually there's two.
Well, 0.
There's only one positive number that stays the same.
So
It's
1.
1.
One.
It's the same.
Yeah. Okay. And then the negative numbers
Just go to the positive numbers.
just go to the positive numbers. So what does that mean about the positive numbers?
Oh, they just.
How do they get hit?
They get hit.
Well, they just stay the same. They're part of our graph.
These numbers over here, how do they get hit by the numbers over here?
Well, every number. So every number here is hit by 2 numbers.
Okay. All the positive numbers.
Yeah.
And then negative numbers.
So,
What about 0? How many times does 0 get hit?
well, 0 just gets hit once.
So only 0 goes to 0. But -1 and 1 go to 1. -2 and 2 go to 4. So every positive number over here gets hit by 2 numbers over here.
Here.
All right. All right, let's go to the second video and look at the real axis.
Alright?
Okay.
Or the imaginary axis. I mean.